Okay, so this is part 2 of our energy video of video 1. So we're going to learn 2 quick terms that are going to be really, really important to chemistry because we need to know, hey, is the reaction exothermic or endothermic? Now, you can see by the prefixes, I'm hoping that you kind of understand what's going on. Exo means to exit or be on the outside. Okay, go outside, go out, outside. Okay. And therm, of course, like thermal underwear, thermal anything like that, is heat, all right, which we've been talking about. So what does this mean? The heat is released or given off, however you want to say it, okay, given out, okay, it's released, it exits, goes away, goes out, okay. Anything that burns would definitely be exothermic because obviously you feel the heat. So when you sit by a campfire, that's why you do it. So you get that heat that is coming out at you. It's released, okay? It flows out of the system. So the change in energy, which we use the value or the variable Q, right? Remember Q, the heat. What will that value be? It will always be a negative value. Okay, so when you're losing heat, it means it's giving it off, it's losing heat. Okay, so when we give off heat, we lose it. Endothermic, endo, okay, is what I say in my head. Endoskeleton means like the inside. So yeah, heat is going to be absorbed or brought into the system, right? Comes in to the system. All right. And what will that mean in our Q, our heat, our change in energy? What is it going to become? It's going to go from something lower to something higher. So it's going to be positive because it's absorbing it and taking it in. Whereas the change in heat here, it's going to lose energy. So we start at a higher amount and then go down. So we've lost and we have negative energy that we've lost. Okay. So endo and exothermic, we're going to do a little lab with that. And I think it'll be very clear. We've already looked at that on one of our labs. So there we are, really clear on it. All right, so I'm going to do a couple calculations here that we already learned the formula in video 1, delta E equals Q. So the total energy or the internal energy or the change in energy of the system is Q, which is our heat, plus our work, of course, right? Now, we got to read the problems very carefully. This is probably the trickiest part. Just by reading the problems, you got to understand when we have a positive Q and when we have a negative Q, when we have a positive W or a negative W. Calculate the internal energy, so delta E. All right, so we're going to do delta E equals. I got to solve in Q and W, so I got to find the heat and the work. If a system absorbs, whoa, look what that says. That's almost too easy of a problem, to be honest. Absorbs 51 kilojoules of heat. So if I'm absorbing it, is going to be a positive Q, right? And it gets Q because it's heat. Whoops, I covered up the number almost, right? So 51 kilojoules. It's a positive value, so you can write that if you want. Plus, now we got to find the work. Now, I would put this in parentheses when you're adding it, just in case it is a negative value and you don't lose it. And it does 24,000 joules of work on the surroundings, okay? So when we talk about systems, remember the system, whatever we're looking at, the system, the surroundings, it's doing work on the surroundings. So it's doing the work. When you do work, I'm sure you probably get tired. And that is a negative feeling, right? So when you do work on the surroundings, now if work is done on the system, then that would be a positive. But this case, it is going to be a negative W. So that is 24,000 joules. All right, now there's a couple things that I need to bring your attention to. If you notice, this is kilojoules and this is joules, all right? So no, okay? Did it ask me to give it in a particular unit? It did not, okay? So let's just go ahead and kilojoule. So my 51 will still be fine, okay? But I have to convert this negative 24,000 into joules. Now, remember, I'm going to do a quick little over here, but many of you guys can do this in your head. We have joules on the bottom because we don't want them. We want a kilojoule. There's always one for the bigger unit, the kilo, and there's 1,000 joules in it. So we just divide by 1,000, which means move the decimal back 3 places. So that would be just negative 24 kilojoules. So we take 51 and we're going to add a negative 24, which means 51 minus 24, which is 27 kilojoules. Now pay attention also and then make your answer nice and neat there. that 51 was positive, 24 is negative, so you know it's going to be positive overall. So just watch your calculations and make sure they all make sense. All right. One more. Go ahead and pause the video for a second and then come back and see if you got this one right. I'd like you to try it on your own. Calculate the change in energy. So again, we're going to change in energy it. We need the Q and the W. So let's start reading. For a system that performs 20 kilojoules of work on its surroundings. Okay, you can read on a little bit more too if you want to highlight. So it's performing. That means it's doing work on the surroundings again. Okay. Now, again, if it was performed on the system, then we would get a positive. But this is a negative W yet again. And whoa, it loses 65 kilojoules of heat. So that means that my Q is going to be negative. Okay. So my 65 is negative 65 for my Q. It's kilojoules. Watch your units. You're going to add it to, oh, that's a negative again. So negative 20 kilojoules. Oh, wow, they're both kilojoules. So that's a much easier problem. All I got to do is add those two negative numbers. Of course, adding two negative numbers gives me a bigger negative number. Negative 85 kilojoules. Perfection. All right. Now, I'm just going to quickly mention these two last formulas. You guys are going to try one of these. I'm not going to do the actual examples. I want to see how you guys do just getting a little bit of information and utilizing it. So for the whisk, you're going to do one of these formulas. I won't tell you which one yet, so you can look at it. You can actually find it pretty quickly. But kinetic energy, so our types of energy, is the energy of motion. We should all know that. That's what temperature is measuring, the average kinetic energy in our world, right? So it's very, very important. There's also kinetic energy of anything moving. And how we calculate that is the formula is 1/2 mv squared. Now, the mass has to be in kilojoules, okay? I mean, kilograms. Hello. We gotta have a mass unit, which is a little tricky. And then our velocity is in meters per second squared usually, okay? Now, it's order of operations here. You've got to square this first. So this has to be done first. Then we can multiply by the mass and then divide by 1/2. So you do have to follow operations, okay? Velocity is speed and direction. Potential energy is the energy of position. I do want you to just know these definitions. And that means what we stored up, okay? Batteries have potential energy. They have energy stored within them. We all have potential, right? Some of you guys hear that more than others, right? Potential energy is, we usually think about this in the physical world as something falling or something like that. I call it MG. I know it's kind of a funny formula, MG. Again, the mass has to be in kilograms. The G is something we just know. G, it's 9.8, meters per second squared. So that is, it's what every object, if it did not have air interfering with it, because we ignore it, that was what it will accelerate to the ground at. So even a bowling ball or a piece of paper, if we took away air resistance, I could put the paper and the bowling ball and it would fall at the same time. I may be able to show you a cool video on that. And H is the height that it falls from. So that would be meters again. All of these units are joules. Okay. So just watch. The biggest mistakes when you're solving these problems is not converting the mass to kilograms. Let's see how you guys do.